Hello, sir. Our experiment name is Encoder and Decoder using logic gates. Our team members are Mukiran, Sabaresh, Netaji, and myself, Parvati. Hmm, First, let's see about the encoder. It is a simple device that converts the data from one format to another format, like electrical signals to counters. So, this is a block diagram. In this, we have 2 to the power n input lines and n output lines. So, in this experiment, now we are going to see about 8 is to 3 encoder. It has 8 input lines and it is producing 3 output lines. This is a logic diagram. So actually, encoder it is a simple circuit or a transducer that converts binary information which is already in the form of 2 to the power n input lines into n output lines, which represent n bit code for input. So in the encoder, the feedback signals will determine the position, count, speed, and direction, and the other control devices they are used to send the command to the particular functions. So, for generally the in case of encoder, we will it will be considered on the transmitter side, but whereas for the decoder, it will be considered on the receiver side. Mm, so in the circuit we need 9 OR gates. So let's see how the connections are given. And that's all. Now let's check how it works. This is truth table. Only one line will be active at a time. So if we give one for third input, second and third bulb are glowing, and for fourth and then for fifth 1 and 3 are glowing, and then for sixth 1 and 2 are glowing, and then if you give one for seventh input, all the bulbs are glowing, and that's it. Now let's see about the decoder. It is multiple input and multiple output logic circuit. This is the block diagram. So it has n inputs and 2 to the power n possible outputs. So in this experiment we are going to see about 2 into 4 decoder. If you give 2 input, it will produce 4 output lines. This is the truth table. In this we have one extra input that is named as enable input. So this is the logic diagram, and actually decoder it is simple logic circuit as same as the encoder, but it performs a reverse operation of encoder. It decodes n inputs into 2 to the power n possible outputs. So here the input code generally has fewer bits than the output code. So earlier we have seen in the truth table about earlier in the truth table we have seen about the enable input. It will be mentioned as E. So if we give 0 for E, then it means that the decoder is disabled. So all the outputs will be 0. So if E is given as 1, then it means that the decoder is enabled. Then the desired output will be produced. So in the circuit we need 8 AND gates and 2 NOT gates. So and that's all, the connections are given. So now let's check how it works. This is truth table. Now the enable input is given 0, so all the outputs are 0 now. If we give 1 for enable input, now the decoder is enabled, so output is produced. If we give 1 for A, 1 for B, then a second bulb is glowing. Then now if we give 1 for A, then third bulb is glowing, and at last if we give 1 for both A and B, then last bulb is glowing, and that's all. Thank you, sir.